Last time, we compared machine learning, deep learning, and neural networks. But how do these systems actually get better with experience? How does a machine go from knowing nothing to correctly predicting answers? That's where training comes in. In this lesson, we'll walk through the entire AI training process, from data to error calculation to optimization, so you can see how AI models really learn step by step. AI doesn't magically know things, it learns from data. Training data consists of examples paired with the correct answer called labels. Example: if you want an AI to recognize cats, you feed it thousands of labeled cat versus dog images. Think of data like flashcards. The more high-quality cards you study, the better you perform on the test. Bad or biased data equals bad AI. Key takeaway: the quality and quantity of training data directly determine how well an AI can learn. Making a guess. At first, the neural network makes random guesses. Input flows through the network layer by layer until it produces an output like 90% cat, 10% dog. Example: if shown a cat, it might guess dog. That's okay. Mistakes are part of learning. Key takeaway: the model has to guess first, then improve. Measuring mistakes. The loss function measures how wrong the prediction was. Example: if the AI said dog when it was actually cat, the loss is high. If it said cat with 95% confidence, the loss is low. Think of loss like a teacher's red pen. The more red marks, the worse you did on the assignment. Key takeaway: loss functions give the AI feedback on how far it is from the right answer. Learning from mistakes. Once loss is calculated, the AI works backwards through the network, adjusting connections weights. This process is called backpropagation. Imagine shooting an arrow at a target. If you miss, you adjust your aim a little bit before the next shot. AI adjusts its aim millions of times until it consistently hits the bullseye. Key takeaway: backpropagation is the self-correction mechanism that lets AI improve. The gradient descent process. Adjustments aren't random, they follow a mathematical strategy called gradient descent. Gradient descent tweaks the model step by step, moving it closer to the lowest loss possible. Imagine hiking down a mountain in the fog. You can't see the bottom, but you can feel the slope under your feet. Each step you take downhill gets you closer to the valley. That valley equals the best version of your AI model. Key takeaway: gradient descent helps AI gradually minimize errors. Training over time. This whole cycle repeats millions of times across huge data sets. Each pass through the data is called an epoch. With enough epochs, the AI becomes highly accurate. In early epochs, a cat versus dog classifier might be 50% accurate. After dozens of epochs, it could reach 95% accuracy. Key takeaway: AI gets smarter through repetition, just like people practicing a skill. When AI memorizes instead of learning, problem: AI can sometimes memorize the training data instead of actually learning patterns. This is called overfitting. It performs great on known data but fails on new data. Think of a student who memorizes practice questions but can't answer a slightly different test question. Key takeaway: true learning means generalizing, not memorizing. So now you know. AI improves through data, loss functions, backpropagation, and optimization. It's not magic, it's millions of tiny corrections happening at lightning speed. In Lesson 5, we'll explore real-world challenges in AI training, things like bias, data scarcity, and ethical concerns, and why training responsibly is just as important as training effectively. Subscribe and hit the notification so you don't miss it.